Good afternoon. We are from Team 11P, presenting a cost prediction model that we have built with Python and Power BI. Our objectives are to firstly create a predictive model using machine learning to predict the contract costs of future projects. And secondly, to integrate the model with a user-friendly visualization tool. And overall, our analytical pipeline starts by firstly doing data explorations and preprocessing, followed by modeling, and finally integration with Power BI.
Exploratory data analysis. In feature reduction, we employ correlation analysis for numerical variables. The graph shows that although floor area and building costs are correlated to the target variable, they are also positively correlated between them. Hence, building cost is excluded from the model analysis.
Additionally, we looked at the impact of some categorical variables such as building usage as well as construction material. And as you can see from the box plot below, they have a positive impact on cost and should be taken into account when doing the model.
We train an extreme gradient boosting random forest model in Python as the predictive model that will be integrated with the dashboard. Whilst its predictions were robust for relatively less extreme training data, subpar performances were found for the opposite. The model has a great potential and flexibility, but more training data will be needed to improve the performance of the model. Another functionality available in the dashboard is locating historical projects that are similar to that of the new inputs using a clustering algorithm, as manual screening is difficult with the high-dimensional data. We also propose the integration of a T-distributed stochastic neighbor embedding algorithm with the clustering algorithm if the number of input variables are expanded drastically in the future.
Excel is a user-friendly and universally familiar tool. Therefore, we decided to use Excel as the backend by which we can enter the details of a project for which we want to predict the contract cost. This is done through the use of an automatic form by clicking over here. And the project details are entered in these fields. We enter the details and save the file.
By refreshing, the Power BI updates new data and runs the Python script to make the predictions. The dashboard displays the forecasted values for inputted projects and provide the user with a way to interact with the results using main construction, type of work, and ID segmentation objects. Visualization provides two metrics, total contract cost and unit cost. The first table represents the confidence interval of the predictions. The pie chart illustrates the share or percentage of cost when multiple inputs are made. Lastly, the combined bar plot shows a comparative view between predicted cost by project ID.
The dashboard takes the predicted cost value and displays the list of comparable historical projects that are similar to the project in terms of their input variables. This is done using a clustering algorithm in Python, and the fellow cluster members of the selected project are displayed in the table over here. Further, the chart on the right-hand side displays how the predicted contract cost is placed relative to the minimum and maximum project cost of comparable projects.
For instance, when we select the value we just inputted, we'll see how the charts varies according to the selected cluster, which in this case is 0.
Adding external factors will help us improve our model accuracy, especially that they can be easily implemented in our XGBoost model. Location, for example, is one of the major factors that could impact cost. Each construction site has its own cost, while time series of some economical factors will capture the inflation of the current year and years to predict. Finally, number of laborers and labor wage rates can be added to boost performance. When answering this question, and after implementing the XGBoost model, we were able to extract which feature had more impact on the outcome or on the cost. And as you can see from the figure below, construction material had higher impact than the building usage. Keep in mind that this outcome was given only from the data or past projects that were given to us.
To answer this question, we summarize it in 3. Firstly, visualization is definitely key. As data analysts, we strongly rely on visualization to provide valuable insights to a non-technical user in a more understandable way. This is extremely useful to back up our results and recommendations. Also, it is helpful to create interactive dashboards to improve user experience like Dash or Power BI. Lastly, automating the process in the back end also helps, as the user does not have to implement technical skills. For instance, we did that in this challenge with the Excel template to facilitate the tools to the user.